Hello friends. Welcome to our YouTube learning channel. Accurate. ASME. ISO. This video will guide you while using the probe stylus on CMM. Please do not forget to like and share the video. Let's begin now. Contents. The importance of Stuli for precise measurements. Selecting and using Stuli. Choosing a Stuli. Stylus types. Accessories. Extensions. Materials used. Calibrating Stuli. Scanning. Ball precision. Cap or spigot ball assembly. Summary. Importance of Stuli. Quality assurance standards have increased dramatically in recent years along with stringent tolerances. Companies can only remain competitive if they deliver top-class process stability and superior quality, and all as rapidly as possible by upgrading their coordinate measuring machines. The quality of Stuli and accessories plays a vital role in precision measurement technology. The stylus is the first link with the workpiece. Therefore, it is vital that the stylus delivers the greatest possible accuracy at the point of contact. Selecting and using Stuli. For selection of the Stuli, one must know the thread size of his CMM's sensor. Connecting thread. They are usually available in sizes M2, M3, M4 or M5. Stuli can be used very flexibly with the help of thread adapters. For example, you can use M2, M3, M4 Stuli on M5 sensor connecting threads. The geometry of the workpiece determines the choice of stylus component. A stylus must be able to easily reach all the workpiece's probing points. If you want to take all the measurements for a workpiece on a coordinate measuring machine equipped with a fixed sensor, you often need several Stuli, mounted in different orientations, requiring different shaped Stuli components, extensions and knuckles. The combination of all these components is known as the stylus configuration, which is mounted on an adapter plate. Choosing a Stuli. A Stuli has 4 dimensions. A ball diameter. B. Overall length. A standard description of overall length is measuring from the rear mounting face of the stylus to the center of the ball. C. Stem diameter. D. Effective working length. This is measured from the center of the ball to the point at which the stem will foul against the feature when measuring, normal, to the part. To maintain accuracy at the point of contact. Keep Stuli short. Minimize joints. Keep the ball as large as possible. Stylus types. Straight Stuli. They are used for simple features with which direct contact can be made. Straight shouldered stems and tapered stems are available. Stuli with tapered stems offer better rigidity when the workpiece is easily accessible. To prevent stylus bending, you should use the shortest stylus possible, particularly with touch trigger probe systems. Star Stuli. These are multi-tip stylus configurations with rigidly mounted styli for surfaces and holes with which direct contact can be made. This configuration gives flexibility, enabling the tip to contact different features without changing the stylus. Swivel styli. This is a clamping mechanism that can be for angled surfaces and angled holes, used to adjust styli to the required angle. This configuration gives flexibility, enabling you to contact different features without changing the stylus. Disc styli. These styli are sections of highly spherical balls and are available in various diameters and thicknesses. These styli are used to probe undercuts and grooves within bores, which may be inaccessible to star styli. Semi-spherical disc styli. These styli have a huff ball, or roller, mounted on each face of the disc, both beneath and on top, which guarantees point contact in the Z direction. Also, for undercuts, stepped bores and grooves within bores. Cylinder styli. For measuring sheet metal, pressed components and thin work pieces with which proper contact cannot be guaranteed with ball styli, cylinder styli is used. In addition, various threaded features can be probed, and the centers of tapped holes located. Ceramic hemispherical styli. Their advantage is that they have a large effective ball diameter with minimal weight. For measuring deep features and bores. Suitable also for contact with rough surfaces, as the roughness is mechanically filtered out by the large diameter surface. Accessories. Accessories are useful for adapting probe components more precisely to specific measuring tasks. Bodies, cubes, combine to create specific styli configurations. Knuckles. The angular alignment of the probe component for making vertical contact with angled workpiece surfaces or angled holes. Knuckles must be extremely stable and precisely machined if the probing force is not to alter the position of the stylus tip while measuring. Extensions. They are used for measuring very deep features and bores, or probing points that are difficult to access. As is the case with stylus components, the choice of the material of extensions is important in metrology. With long extensions, you need to pay close attention to the material's thermal characteristics. Materials used. For holders. The stylus stem is attached to a threaded holder. Steel and titanium are the ideal materials for holders. Titanium is far lighter than steel and should be used when a lightweight assembly is required. Materials used. For stem. The stem must be designed for maximum rigidity to minimize bending during measurement. The materials used can be tungsten carbide. It provides exceptional rigidity, particularly with small stem diameters and shouldered probes. Ceramic. Due to its lightness, Ceramic is mainly used for long styli. It is thermally stable for production-related applications. It can also be used as a break protection in machine tool applications. Steel. For styli with superior rigidity for standard applications where weight is not an issue, steel is used. Ceramic fiber. Also ideally suited for long styli as carbon fiber styli only weigh around 20% of tungsten carbide styli. Its thermal stability delivers huge benefits, particularly with very long styli, and this makes it suitable for use in a production environment. With large stem diameters and long styli, you need to be careful about the weight. Ideally suited for most standard applications. Connecting components. Titanium and carbon fiber. The connecting components are made from titanium with a positive thermal expansion coefficient, whilst the extension tube is made from carbon fiber with a negative thermal expansion coefficient. The two components are designed to match one another so that when heat is applied, the carbon fiber contracts by the same amount by which the titanium expands. The outcome is that these extensions suffer little expansion, even with extreme temperature changes of between 15 and 40 degrees Celsius. Styli components and accessories. The key criteria when choosing a material are ambient conditions, length, flexural rigidity, the permitted masses specified by the sensor manufacturer. Fluctuations in temperature can cause serious measurement errors. Thermal stability. You should always use carbon fiber for very long extensions, as in these cases even tiny temperature differences could otherwise cause major measurement errors. Carbon fiber offers the ideal combination of minimal mass and greatest temperature stability. Flexible rigidity. Styli should be as stiff as possible. In materials technology, the elastic modulus is a material characteristic that describes the relationship between tension and expansion when a solid body is deformed. As the value of the elastic modulus increases, the more resistance a material presents to being deformed. Selecting and using styli. Ruby. After diamond, ruby is one of the hardest materials known, so it is an ideal material for balls in most standard applications. Silicon nitride. It is very similar to ruby in terms of its technical properties. It is an exceptionally wear-resistant ceramic material that can be shaped into perfect balls whose surface can be polished until it is extremely smooth. It is not attracted to aluminium. For this reason, the material is ideally suited for scanning aluminium surfaces as, unlike with ruby, aluminium particles from the aluminium surface are not deposited on the ball. Zirconia. The special nature of this material's surface makes it perfect for scanning the surfaces of abrasive work pieces such as cast iron parts. Scanning. With point measurements, the ball only encounters the component's surface for a very short time. Scanning is different as the ball slides along the surface of the workpiece. Because the contact is continuous, there is a prolonged sliding contact between the ball stylus and the surface of the workpiece. Ball stylus wear and tear and ball stylus deposits left by scanning can affect measurements. Ball precision. A ball's grade is a rating that describes the precision class of the ball used. Precision classes range from grade 48, which is the lowest precision class, to grade 3, which is the highest. Nominal ball diameter. The diameter value used to identify the ball size. Deviation. The difference between the largest and smallest diameters of one ball. Deviation roundness. The greatest radial distance in any radial plane between a sphere circumscribed around the ball surface and any point on the ball surface. Cap or spigot ball assembly. There are two options for connecting the stem to the ball: a cap connection or a spigot connection. Spigot mounted design. This means that we drill holes in the balls down to 0.5 mm diameter, grind spigots on the shafts and bond the balls to the spigot. The advantage is clear: the bond is technically superior in engineering terms and, particularly with slim stems, there is a greater gluing area. Undrilled ball bonded into a spherical cup. Form of the ball can be degraded by both machining a hole in it and through distortion from gluing it onto a spigot. Particularly with slim stems, because of the limited gluing area, conventional bonding methods can result in the ball quickly separating from the stem when even a minimum of force is exerted. Calibrating stili. The position of the individual ball stili and their diameters are established using a special probe calibration program. You contact a reference point with all the stili to be used, one after the other. The reference used is usually an extremely precise, manufactured ball with a known diameter. The exact dimensions of the ball being calibrated are input to the measuring software. The probe calibration procedure establishes the stylus tip's effective diameters when measuring, and their positions in relation to one another and to the machine's coordinate system. Summary. Different shapes of stili are: straight stili, star stili, disc stili, cylinder stili, pointer and ceramic hollow ball stili. Stili are available in a range of ball diameters such as 0.3 mm, 0.5, 0.7, 1, 1.5, 2, 2.5, 3, 4, 5, 6 and 8. Stylus are also available in various lengths such as 10 mm, 20, 30, 40, 50, 75 and 100 mm.